I've started the recording. This is the lecture for Design 330. It's Tuesday, April 13th, and we're going to look and see what to do this week. I have not yet graded your product book. Sorry about that, but I'll be getting to it as soon as I get a chance. But we're starting into the new area, which is the HVAC, or maybe I did do those. I don't think I did your research. But we're doing the MEP basic design of your HVAC sheets now. Those are your M out of the MEP, mechanical, heating, ventilation, air conditioning. So there's a playlist for you to look at. It's got a bunch of, it's actually got all the things step by step of what to do. And so you should be able to just follow those to go step by step. There's a submittal template, which is basically your executive summary and lay out your air terminals. That's done in AutoCAD. And it's just to sort of get it as close as you can and get it about right. These are the preliminary designs. And then a mechanical engineer would take your HVAC design and zip it into shape. No, we'll use this register that has a little bit more of this, and we'll do this and that. So this, you just need to be kind of close with it to give a very, very good idea to the mechanical contractor who's going to do the air terminals. And then we have part one, which are your HVAC sheets from an MEP building set. And we're going to use B size standard, and that's going to be portrait using the standard title block. And you're going to have some views. You're going to have M01.1.2, M02.1.2.3, and these are the things that go on it. Space plan from your zones. You did that one last week. Air supply, zone 1, or supply air, zone 2, supply air, zone 3. Now, each one of those, I expect to take you about 15 minutes to do once you've got the models done. And your models for each of these should take you about half an hour to an hour if you've got your layouts all done. So there's a chunk of work here. There's 10 to 12 hours. Of course, this is a 5-unit class, and you're expected to put that time aside. So once you have your models and your sheets done, that's only part of it. Then you need to show your schedules and your calcs. This is a really important part of a drawing set. People need to know what the equipment is. So we're going to have a mechanical equipment schedule, an air terminal schedule, a duct fitting schedule, air handler and thermal sizing calculations, and supply register calculations. And those are all going to get arranged on M02.1, 0.2, and 0.3. This one should probably, tell you the truth, be somewhere else, but we'll figure that out as we go. And then you'll have your detail sheets. You've done 2 details already, detail 1 and 2 of mechanical. You have 2 more details to make this week that are mechanical, so you'll put those on another sheet. So you see your plan views are M01. Your calcs and schedules are on M02 sheets. Your details are on M03 sheets. And then your cool visuals are on M04 sheets. Okay. And then part 2, you're just going to do 6 more details. You did 6 last week. You're going to do 6 this week. Each one, I expect you to take 20 to 30 minutes to do a detail. Okay. And those again are in this folder here. Access to your report and files are in the same place as last time. You do have a discussion board posting. So let's go take a look at that. Hope it's going to, there it is. So you're going to record yourself using the discussion board record tool or a Zoom record, or some system of your choice. And I want you to explain how you determine where to put the air terminals for zone 3. And you'll explain how many there are, CFM for each one, how the total compares to the CFM max from your spreadsheet, the throw for each register, your spatial principles you used. And so that's just going to be using you'll go to reply, and it's over here under record. Upload or record media. So I don't care how you get the media. You can, it's here we go. It's going to be record. You're going to see me. There it is. And I'm ready to record. And I'll just read my stuff and say what I did and all that kind of stuff. Down here it says start recording. And I can use the webcam or not. If you don't want to use the webcam, you can just do a mic recording. They don't have share screen, which is a bummer. I wish they had share screen. But if you'd like to, you could use PowerPoint and show your work, or use a Zoom meeting. But this is talking. It's not typing. It's not doing anything else. And so, look, what I'm telling you is that when you're working, you have to explain why you did things. You have to be able to say it. And so I'm going to require that you say it. Typing it is not an option. You have to actually say it. And that's okay if it's hard for you, make yourself a script, write it out, and then just read it, whatever you want to do. But this is a key part of the design process and general workplace practices. You're going to have to tell people why you did something. And so this is our way of doing it. And then you'll be asked to, when you see one, reply with a voice recording and just, again, get down there. Thank you. Your explanation was very clear and I can follow it easily. Or, thank you. Your explanation was very clear, but I'm not able to understand your spatial principles that you use to place the air terminals with. Or you'll say, thank you. I listened to your explanation, but I was very unclear as to what you presented. So those are kind of and you'll just say one of those things. All right. So this is, again, it's not too tough. You do have to do at least a voice recording. And it's best if you can be there and let people see you too. Because that is the way it is in the working world. However, if you don't have a camera, it could be you don't have a camera, you can do a voice record or something like that. You can, of course, just use your phone and do a voice recording on your phone and upload that. So it's up to you to figure out how to do it. Okay, but this is your easy way of doing it. Go to record. If you don't want the video on, you can turn it off. And you can just talk. I'm going to have to get right up on it and really speak because it's not really catching too much there. But that's okay. And start recording. There we go. And you can have other ways of doing it too. Let's see. Oh, I need to get out of that. Let's see. I'll close that up. So that's what's coming up. Now, let's talk about what we've got going on. We've got this playlist. This is step by step by step. And there's a little over an hour here. So you can watch those. I'm not going to go over those. These are not too bad. They're not too bad. I'll do some quick demo, but I'm more interested in teaching you about why you're doing these things instead of how. But I will do some quick demo. What's more important is you understand what's going on. So I'm going to open up the Jamboard here, and here's a little HVAC system, and I'll tell you, this is This is it. This is the schematic. This is how it works. So I'm going to show you that this AHU, air handling unit, that's what we're putting on the roof. That's the thing that's the number of tons. It's where the heating and cooling happen. The air blows across coils or heating elements or cooling elements, and the air either gets hot or it gets cold. And over here on the compressor, okay, the right, so there, if there's cold fluid in these and the air goes over it, the air gets cold and that gets a little warmer. So the warm stuff comes back, comes through the compressor, and since it's refrigerant, when it goes through the compressor, it gets cold again. That's all you really have to know. There's tons of stuff online about how this works and enthalpy and entropy and that and thermal blah blah blah. No. Okay. The air picks up the cold and the fluid in here gets warmer. There. And when it comes back, it goes through the compressor and gets cold again. And so by the time it gets pumped back to the coils again, it's cold. And more air can pick up the cold and so on and so forth. And the same thing happens on heating.
Sorry, Randy, I have a quick question.
Yeah.
So where in here, because I remember water comes off the system and you have to like do something with water.
Yeah.
Is that in the cooling process, then moisture comes out of the air? What's the water element? I just didn't understand that.
The water is that this stuff always condenses and drips. And sometimes it drips a lot. It's just when the air goes across the coils, it gives up water. it just condenses out of the air. And
so it's just the change of temperature and it's on the exterior. So it's not that there's fluid running necessarily through the system, right? It's correct. A cooling now, liquid, but not water.
That's right. Now that's the way that we're doing it. There are systems that just take cold water and run it through these coils and then dump it down the drain, right?
Are those swamp coolers?
Yeah.
Okay. Gotcha.
And so, but we're using, since it's a big building, we're using a little bit better. So yes, there are systems that just feed cold water and it uses the evaporation of the cold water to blah, blah, blah. And then you have to, it all drips out and goes down the drain. But for us, what you're going to see is they call it condensate return or condensate drain. And so you can just think it's like these just get all wet and it goes drip, 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 and it goes to the bottom of a pan and it collects and it just goes out the drain. So that's how the ones that we generally tend to see work on a big building.
Okay, got it. Yeah, I was just wondering where the water came from. So yeah, because I remember always seeing puddles underneath. Cooling systems. So.
Yeah, and that's mostly what it is in most of the ones that you would see. Okay. Now for the heating side, that can be different. The heating can be done a bunch of different ways. If it's called a DX or a heat pump, they just run this compressor backwards, essentially, and it heats stuff through the coils, and this gets hot air and it comes back. But often you have a separate set of heating coils. They're attached to a gas line, and you just fire it off, and it's just like, it's a burner can. And those ones need a gas vent because you can imagine you're burning gas and you're passing hot air through tubes of burning gas, and it just goes off. But the heat often, this is called a split system, where the cooling coils go to a compressor and the heating coils are either sort of like your stove, and you've got stove elements that are hot that your air goes over that are electric, or it's more like your stove that's a gas stove and you've got the burner but those burners are inside little cans or little tubes, and the hot air goes over those. So we don't really care. We're actually not designing this part. We're leaving that off because it's not super important to the layout of the rooms. We're going to put this big air handler on that's going to have cooling coils and heating coils and a fan. And we're going to have a big return duct that feeds it back, although we're not designing that part. We don't have enough time. And we are going to do this part. The air is either hot or cold, and it has to distribute out to the building. And it goes through ducts, and it comes out these registers. Now, often you see these ducts get smaller and smaller and smaller as you go, because you can imagine this part of the duct has all of the air going through it. So it has to be bigger. And this part of the duct has less air going through it. Hi, Wasan, you're back with us. That's good. That's cool. And so this duct can be smaller because it's got less air going through it. And toward the end of your line, it can be even smaller because you can have even smaller amount going through it. Now, we're not going to really bother with that too much because in Revit, once you have your model made, it's so easy to change the sizes. And we're mostly interested that you can get the model made. We'll let the mechanical engineer pick the sizes, although it's very easy to do in Revit. But again, we're sort of shortened down and we're not going to do that part. I'll probably demonstrate it on Friday, but you're not going to be required to do it. But you are going to notice that there's a big piece called the trunk that the branches come off of. So you can just think of it. This is like the roots of the tree, even though it's on the roof. The trunk is where all the action is. It's the big part that's sending all the air. And then where branches come off of it, okay, are the smaller lines. So that's what an HVAC system looks like. And there's a fan, and there are heating elements, basically just tubes that get hot. And there's cooling elements, which are tubes that get cold. And you blow the air across it. And of course, you're only running one of these at a time. You run your cooling system or you run your heating system. Okay. And you blow air across those. They either the air gets hot when it goes across or it gets cold when it goes across. And it goes into the trunk and spreads out through the branches, through your air terminals, and into the room. Now that's very, very simple sounding. And this is one of the most complex parts of any design that you'll ever see because there's so many factors. There's how much open area is there and how much is flowing through and what the pressure is at each one of these spots and how far apart these are and how high up off the ground they are and what the throw is and even how many turns, how often you need to replace the air in this area. So like this air is going to get sucked into here and go out, and it might be different from here. It's very, very complicated. And there are mechanical engineers that calculate this stuff. And Revit is okay. Revit is good for your basic initial design. And then you let the mechanical engineer tell you exactly what size this is and what size this is and how high off the ground it is and things like that. Your mechanical engineer will do that. But when you build your model in Revit and the mechanical engineer gives you your feedback, It's very simple to change. And that's good. Okay, how does that sound? Does that make some good stuff? Let me do one more. I'm going to show you this split system. I'm going to show you the air handler now. And it has just a little bit, now it's a 3D view that's got sort of that. Okay. And so, and they've named things just a little bit differently. So here you've got, this is your air handler unit. And the way they've got it designed is those coils are in what's called an evaporator, which means that you're going to pass air across it. Okay. And so that's kind of an interesting thing. And this tube right here is kind of interesting. That's your makeup air or your exhaust air, because you always want to get rid of some portion of the air that returns. Let's say I've got 100 CFM coming in. You might want 10 CFM to blow out the roof so that you can get new air through here. So that's just a thing. That's just a thing. But this one has an air handler. They've even said, yeah, you need a filter. Yes, you do. We didn't talk about that on the last one. We're not going to talk about it now. And there's a blower in here. But they've put the evaporators in a box sitting on top of the air handler. Okay, and there's the cooling coils. Sorry, the heating coils and the cooling coils. And they're just, again, a representation. And then there's the ducts, the supply duct, air supply ducts. You're supplying to the rooms. And the return duct is returning from the rooms. So that gives, I hope that gives you a nice idea of what the air conditioning system is like. And if you know that, and you've got those numbers that you calculated last week, you're ready to go to town. Okay, you're just ready to do it to it. So let me come up here. I've got a little bit of work to do to get back into a zone where you can see stuff. And I'm just going to discuss some things about the air terminal placement drawing. Wasan gave us that drawing, and I've modified it up just a little bit. So now I need to get into an AutoCAD drawing. I hope I've got it here already unloaded. Air register layout. Where's my air? There it is right there. Okay. So if I open AutoCAD, I'll be able to open that. And mine might look a little different than yours. And so Wasan, I got much better at figuring out how to tell people to do this. So you'll see that I didn't use your presentation just because I was able to really simplify my instructions. So hopefully when you watch my video on it, you'll go, oh yeah, you make a lot more sense now. Because Wasan was trying to make sense of what I was telling her originally. And you would think, I've been teaching this for years, and you would think I could explain it better, but our technology keeps changing. So I'm having to change how I explain it, and sometimes I miss it. There it is. No, I've got it right there. There's the register drawing. And I've got a little bit to do here to fix things up. Ignore my references. That's fine. And I can't stand the black. I know some people love it. Dark mode. Da, da, da. It's horrible. I can't see it. And that'll be good. I'll put 3D parallel. I'll also do white. There we go. Okay, so what you see here are this is a representation of where the air goes in a register. And this little square is a representation of the register. Okay, so your job whenever you do one of these is you sort of have to figure out how many you need and where they're going to go. And you get that from your spreadsheet that you did last week. But you'll notice there were a whole bunch of different ones. I could have a 24 by 24 register and I get a different amount of air if I use a 6-inch neck, an 8-inch neck, a 10-inch neck, and a 12-inch neck. And it's a balancing act. If I push too much air into here, I'm going to have an inefficient, I'm going to be overcooling and overheating and using too much energy. And that'll be bad for my client. If I don't do enough air, when it really gets hot outside, I won't be able to cool it enough. So I have to make some sort of a balance. And so if it says that you need a peak of, say, 900, and you go, well, I need 6 of these registers or 8 of these registers, and it doesn't really match out, it's okay. It's okay if you push in too much air. It's better too much than not enough. But if you double or triple the amount of air that you're putting in here, that's just overboard. That's too much. Okay, so it's a balancing act. And then you have to figure out the more air terminals I put in here, the more expensive it is. Every air terminal costs money. And the installation of an air terminal costs more than the air terminal itself. And so if I've got 6 air terminals and they're not very expensive, let's say each air terminal costs me $25, but it costs me $75 to put it in, I've essentially got $100 per air terminal. Whereas if my bigger, and that would be $600. If I have one big air terminal and maybe it costs me $100, it's still only going to take me $75 to install it. So now I'm only paying $175. So there's always a balancing act, and that's design. And so you're going to you're going to do the best you can, and you're going to write down why you made choices so that you can explain them later on in that video. Okay, so on this one, I think I put down, I used the number of 900. The actual number is something different, right? You guys have that in your Revit thing and in your spreadsheet, but I'm not going to do something that you guys can actually duplicate and copy. You have to do your own. So now I'm going to put this thing here, copy. And I'd like to have a little bit of overlap. You know, it'll bounce around those corners a little bit. Bink. And then I'm going to go look on my spreadsheet and I'm going to find that the throw was like 12 feet. So I have to make this a radius of 12 feet. Radius, 12 feet. Oh, okay. So I can kind of cover this with 4 of them. You do that right, copy. And I don't have to be perfect with this. I can kind of go like that. And then I see that that one would have given me 4 each at, I think that one was like 235, or maybe it was 375. 1350 CFM with 12-foot row. And you would go, oh, well, that looks okay, but look, 1350, that's not terrible. It's less than twice, and I get good coverage. But maybe I would want to knock this down like one size. And I've got good coverage. It's pretty good. And so you're just going to look at this and go, yeah, I wonder if I've got another version I could use that maybe I think the next one was like 9-foot throw or 10-foot throw. And you're just going to play with it and get it right. This is the key to the rest of your design. Once you've got this, your modeling is so simple. Now, when you do zone 2, it's a little bit different. You're going to have to kind of look at each one and go, okay, I'm going to place one in this room, and one in this room, and one in the bathroom, and one in here, and one in here. Most of those are just going to have one. And you're going to have to figure out the placement and what size you're going to use. And most of those are going to be your 6x6 neck at 135. But you've got a couple that are getting up into the 250 range that you'll need an 8x8 neck. So again, it's not, this is actually easier because it's just like 1, 1, 1, 1, 1, 1, 1, 1, 1. There. And just pick the correct neck size. Much easier than trying to figure this out. But you can see the mechanics of this don't take very long. It's the thought process and juggling them around and trying different ones and choosing. And you have to be able to explain your choice. Because then your boss might go, yeah, that's cool. Or your boss might go, you know, at this company, we like to go a little bit overboard on our supply. So I want you to get just a little bit more. Or they might go, you know, we use super efficient equipment and much better registers than anything you'll see here. I want you to slide down to the other end. But you have to be able to explain your choice. Okay? Does that make sense on what we're going to do there? And this is really cool because it does give you a nice visual. It kind of shows, and you can look and see the volume of air. And later on, you'll be able to look at this volume of air. That's the MPROP, the MPROP, the materials property command. And you can find that volume of air and start looking at turns and all sorts of other kind of stuff. Okay, but this is a really nice model for me to work with. I've never had a model like this to work with before. It made the explanation much easier. So thank you, Wasan. Okay, and remember, each of these little things that you see here are one of these. And it's spreading its air in a space, in a volume. Okay. So that's our description of what to do here. And I think you can get this whole thing done in an hour. Okay, but maybe you want to play around with it a little bit more. And a good thing to be able to do would be to copy what you've got here. And now try a different one so that you can really see them side by side and do a comparison. It's really hard if you keep erasing it. So just start it over and just change all these to now a new one. Maybe I'll do one with a 7-foot row. Oh, well, those need to move out, and I maybe need another 2 over here. maybe I need another 2 in the middle or 3 across, and maybe that's not very good, or maybe I want to go different. So you can start playing with those. Does that all make sense? Okay, since that was quiet, I'm gonna guess that it made sense. There we go. Okay, so now once you've done that, you're ready to get into here, and I wanted just to show you what some of these are going to look like. This is an HVAC plan view. Except, excuse me, usually it's shown in course view like that. And these leaders are often made a little bit different. Leader arrowhead is often build target diagonal. Well, we'll put a diagonal on it. Heavy end, triangle, filled target, ... diagonal. Just to signify which little part. Often there's a little loop that you can put on there. But this is okay. So it calls out certain things. And again, the mechanical contractor is going to do all the work. But it's saying, what size this is. And this should have how many tons it is. I don't know what that spit one. And so this actually needs a little bit of text here. Now that I'm looking at it, I didn't do a very good job here. So this one should say elevation from roof, and it should say how many tons. Something like that. So you want to get that information on there. Okay, so it tells you about your air handler. It tells me about each one of my air terminals that are 11 foot from level 1, 135 CFM. And this little thing here says it goes in all 4 directions. And this is telling me that I've got ducting that's 12-inch diameter, and it's at 15-foot center line. So that's basically it. And it gives approximate locations. Now I moved these to be the right location, but you can also change your dimension style to be less precise. Okay, and it's just giving me approximates. 7, 13, 13, this is about 7. 7, 13, 13, this is about 7. 13, 13, this is not quite 13. But that's basically what your mechanical zone 1 layout would look like. So then the question is, how do I get those on there? Okay, I basically started by placing my air terminals. That's the very first thing that you do. You get them spaced right and the elevation right, and you make the right ones. Notice I made one that's got a 24 by 24 face with a 6-inch neck, because that was my original, the 12 by 12. So I just edited it and I gave it a CFM. Okay, when I put it in here, I gave it a CFM. If I've got it, if it noted it down in here, or there it is. my flow on this is I told it these are 135 CFM because that's what my thing said. Okay, and then I've just put down a note. What elevation? Here I put 2 ton, so here I put round ducting, visible. So these are just notes that you would put on there. And I did that in an HVAC view. I just made a duplicate of my 3D view. I made a duplicate of my 3D view. And then I locked the view so that I can't mess it up later on. But that's what I did. I started with air terminals and I placed them. And then I placed my pieces of ducting. This is the trunk and these are branches. Now, I could have made my trunk bigger, but I can do that later on very easily. Very easily I can do that. So I'll do that later on when I resize this thing. And I made my branches about the same size. And these branches I made 6-inch. But it was really easy. I made the air terminals. And then I placed my branches. And I did that all in this view right here. Just by drawing lines. You'll see how I did it. I just went to duct. Went to air terminal. And then I did the connect into. I'll demonstrate that for you. Let's say I put an air terminal right here. Okay. And I'm going to put a big one in. Well, I'll put in another one of these small ones. Say I put another one in right there. And I want that one to be 135. And I have to find out how high I put it. I need it to be 11 feet. No, was it 10 feet? From level 1. So you have to just know where you put it. And this is how easy it is to connect up. I have duct, and you can see I put it at 15 feet. It's 12-inch diameter. It's so simple. Click, connect into, click. If it doesn't just do that for you, you have something wrong. And if you want to see more, you can see, oh yeah, look at that. Put in those little fittings and everything. Isn't that cool? So now I'm going to erase, I'm going to get rid of those. I don't want them there. I just did something wrong. What did I do? I got rid of the wrong one. There we go. That's better. I got rid of the wrong one. Okay. So that's really as simple as it gets. And see, if you know where these go ahead of time, it's really easy to put them in there. I put detail lines in. See, I just laid it out with detail lines. Okay, and once my detail lines were in, I just placed these. And then to place my trunk, it was pretty simple. I just go, oh, well, I need one that feeds these, and I need one that feeds these. That was pretty simple once you kind of got the hang of it. Okay? Isn't that cool? And you're going to do that for each of the zones. Each of the zones will get one of those. Okay, and again, I'm just going over the basics of it because the playlist has all the details of how to do all of those things, and you can just watch those and get it directly. So the last thing we need to look at is how do you make your visuals and, well, let's see. Before I do that, let's go to how do I put these tags on here? That one always is a problem. So if I need to tag something, I'll be able to put my tag on, but it might not be right. So remember, I'm always going to go in and check out my things. Now, if I want to, I can put a prefix on here that says elevation from level 1. And it looks like this is going to have to be a little bit wider. You see how that, did that notes for me? And I can do the same thing over here if I wanted to. Edit the label, and I could put elevation. I'm going to put a space this time. From the roof. Okay. And I think there's a thing in here for the size too. Elevate. Flow, comment, description. The description might be the tons. Let me see if that's on there. Let's see if that does it. But now I can get rid of this one. No, that's all it did there, I think. Okay, so I still need that, but now I've got elevation 1.0 from the roof. So you can work on these tags. Okay, and then I show you how to do pretty much the rest of it. I'm going to pull this over a little bit. I like these things to look clean if I can. So that they're in a spot without too much stuff in it. Looks like actually I should bring this down here. That's a little bit cleaner. I want to, I think, I'm not sure if I can add a leader to that. But I can say typical. But now this one can come down over here and get a better tag. There we go. All right. So that's how we put those on. And we're using just the regular title block. Okay. So that title block is from the 11 by 17. That's just load title blocks. We're just using the plain old 11 by 17. M01s are plan views. M02s are schedules and calculations. What am I missing? Where are my M03s? Let's go back and see. What did I not put on there? Oh, those are the details. Well, you know how to put details on. M03s are details. Might as well go put that in here. I'll make a new sheet. Details. So there we go. And you can put your details on here. Okay, and you should either have 2 or 3 per sheet, depending on how you sized them up. If it's an 8.5, if it's like essentially you know, an 8-inch box that's going to fit right here, or maybe the two, you can get two over here. So you just have to size them so they fit on here nicely. So there we go. That is the essence of your mechanical set. Plan views, schedules and calcs. And again, this is just right out of your, I just took a snip. And this is a schedule. And I gave you the I gave you a thing on how to make that. Details and 3D visuals. So I'm gonna see if I can get 6 of them on here. You could get 1 or 2 or 3 per, but you can see I've got 2 zone 1s. I've got from above and from below, because this one gave me a little chance to write a little bit more, and this one gives me the visual of where it is. And I might put the whole building here. Probably actually be even better to put these ones over here and put my whole building here.